19.5 gram of CH2FCOOH is dissolved in 500 gram of water. The depression in freezing point of water observed is 1 degree Celsius. Calculate Van Hoff factor and dissociation constant of fluoroacetic acid. So we have to calculate Van Hoff factor, dissociation constant, that's Ka. Here the depression in freezing point is given. So we know the formula delta Tf is equal to I into Kf into m. Here delta Tf is given already. Let us calculate first molality. Molality is equal to number of moles of the solute, that is mass of the solute by molar mass of the solute divided by mass of the solvent in kilogram. So into 1000 W1. Here mass of solute is given as 19.5 gram. So we can write W2 as 19.5 into 1000 divided by molar mass of solute. So we have to calculate M2. That's a molar mass of solute. That's for CH2FCOOH. Here we have 2 carbon atom. So 2 into 12, 24. And we have 3 hydrogen atom, 3 into 1, 3. And 2 oxygen atom, 2 into 16, 32. Plus 1 fluorine atom, it is 19. So when we simplify this, we will get 78 gram per mole. Now let us substitute here. M2 molar mass, we got it as 78 into mass of solvent is 500 gram. So for converting into kilogram, 500 by 1000, that went to the numerator. So when we simplify, we will get 2 into 19.5, that is 39 by 78. So it is, we can divide. So we will get 1 by 2, that is equal to 0.5 mole kilogram raised to minus 1. Now we got molality. Vapor pressure of water at 293 Kelvin is 17.535 millimeter mercury. Calculate the vapor pressure of water at 293 Kelvin when 25 gram of glucose is dissolved in 450 gram of water. Here vapor pressure of water, that is the pure solvent. So we can write it as P10 is equal to 17.535 millimeter mercury. Now mass of solute is given as 25 gram. Mass of solvent is given as 450 gram. And molar mass of solute is equal to, here the solute is glucose, C6H12O6. So 6 into 12 plus 12 into 112 plus 6 into 16. So when we simplify, we will get 180 gram per mole. Now we have to find out the vapor pressure of the solution after adding 25 gram of solute. So we can apply the Rolle's law, relative lowering of vapor pressure equation. P10 minus P1 by P10 is equal to chi2 is equal to N2 by N1 plus N2. For dilute solution, we can neglect N2 from the denominator. So we can write P10 minus P1 by P10 is equal to N2 by N1. Now P10 is given as 17.535 minus P1 by 17.535 is equal to mass of solute is 25, molar mass is 180 divided by, then mass of solvent is 450. Here the solvent is water. So water, its molar mass is 18 gram per mole. So we can substitute 450 by 18. So that is equal to 25 by 180 into 18 by 450. So we can cut, we will get 10, 25 by 4500. Now here 17.535 by 17.535 will be 1 minus P1 by 17.535. We can divide by using 17.535. Both terms we divided. So we got 1 minus P1 by 17.535. Now 25 and 4500, when we divide, you will get 1 by 180. Now 1 minus 1 by 180 is equal to P1 by 17.535. So when we take the LCM, 180 minus 1 by 180 is equal to P1 by 17.535. That is equal to 179 by 180 is equal to P1 by 17.535. Therefore, P1 is equal to 179 into 17.535 divided by 180. So that will be equal to 17.44 millimeter mercury. Henry's law constant for the molality of methane in benzene at 298 Kelvin is 4.27 into 10 raised to 5 millimeter mercury. Calculate the solubility of methane in benzene at 298 Kelvin under 760 millimeter mercury. So KH is given as Henry's constant. KH is given as 4.27 into 10 raised to 5 millimeter mercury. Then pressure is given as 760 1 atmospheric pressure 760 millimeter mercury. So according to Henry's law, we know P is equal to KH into chi of methane. So here we can find out the mole fraction of methane is equal to P by KH. P is 760 millimeter of mercury divided by 4.27 into 10 raised to 5. So 760 divided by 4.27. When we simplify, we can take 10 raised to 5 to the numerator. So we will get 1.78 into 10 raised to minus 3. That is a mole fraction of methane in benzene. 100 gram of liquid A molar mass 140 gram per mole was dissolved in 1000 gram of liquid B molar mass 180 gram per mole. The vapor pressure of pure liquid B was found to be 500 torr. Calculate the vapor pressure of pure liquid A and its vapor pressure in the solution if the total vapor pressure of the solution is 475 torr. We know according to Rolle's law the total pressure P is equal to PA plus PB, that is equal to P0A chi A plus P0B chi B. So first let us calculate mole fraction of any one component. So we can find out mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. For that, calculating number of moles, we should know mass of A and molar mass. So mass of A is 100 gram and its molar mass is 140. So again 100 by 140 plus 100 by 140 plus Then it is dissolved in 1000 gram of liquid B. So mass of liquid B is given as 1000 and its molar mass is given as 180. So let us simplify this. So 10 by 14 means we can divide by using 2. So we will get 5 by 7. 5 by 7. Here also 5 by 7. So 5 by 7 divided by 5 by 7 plus this number is we can divide by using 2. So 9, 50 by 9. So we will get 50 by 9. That is equal to mole fraction of A. Now let us simplify this. 5 by 7. Let us take LCM. 63. Then 9 into 5, 45 plus 7 into 50, 350. So that is equal to 5 by 7 into 63 by 395. So when we simplify this, we will get 0.114. So mole fraction of A we got. So mole fraction of B is equal to 1 minus 0.114. So when we simplify, we will get 1 minus 0.114, we will get 0.886. Now we got the mole fraction of both. Now we can go back to the equation. PA we know P0A into chi A. Here we got chi A as 0.114. So P0A we don't know. So we can write 0.114 into P0A. Similarly, PB is equal to P0B into chi B. But P0B is given in the question as 500 torr, 500 into 0.886. So we will get 443 torr. Now we know P is equal to PA plus PB. So PA is equal to 0.114 P0A plus P0B chi B is 443. And the total pressure is given in the question. Total pressure is given as 475. So instead of that, we can substitute that. So 475 minus 443 is equal to 0.114 P0A. So therefore P0A is equal to 475 minus 443 divided by 0.114. So that is equal to 32 divided by 0.114. That is equal to 280.7 torr. 280.7 torr. Now we can substitute PA is equal to P0A into chi A. We got P0A as 280.7 and chi A as 0.114. So when we multiply, we will get 32 torr. 16 and 12 in form ideal solution over the entire range of concentration. So ideal solution is a solution which obey Rolle's law. The vapor pressure of pure benzene and toluene at 300 Kelvin are 50.7 millimeter mercury and 32.06 millimeter mercury. So here vapor pressure of pure benzene is given as 50.71 millimeter mercury and P0 toluene C7H 8, that is equal to, that is also given 32.06 millimeter mercury. Now calculate the mole fraction of benzene in vapor phase if 80 gram of benzene is mixed with 100 gram of toluene. So mass of benzene is 80 gram and mass of toluene is 100 gram. So first let us find out the number of moles of each component. Number of moles of benzene is equal to mass by molar mass. So 80 by molar mass of benzene is equal to 12 into 6 plus 6 into 1. 72 plus 6, 78 gram per mole. So 80 by 78. So we will get 1.026 mole. Similarly, we can find out the molar mass of C7H8, that's toluene. 12 into 7 plus 8. 84 plus 8, that is equal to 92 gram per mole. Now let us find out the number of moles of toluene C7H8, that is equal to mass of toluene is given as 100 and molar mass it is 92. So that will be equal to 1.087 mole. Now we got the number of moles of each component. Now let us find out the mole fraction of benzene, that is equal to number of moles of benzene by total number of moles. Number of moles of benzene plus number of moles of toluene. So that is equal to 1.026 divided by 1.026 plus 1.087. So when we simplify, we will get 0.486. Now we got the mole fraction of benzene. So mole fraction of toluene will be sum of mole fraction of benzene and toluene equal to 1. So we can subtract from 1 minus 0.486, that is equal to 0.514. Now we got the mole fraction of benzene and toluene. Now according to Rolle's law, partial pressure of each component in solution is directly proportional to its mole fraction. So partial pressure of C6H6 equal to P0 C6H6 into mole fraction of C6H6. So here partial pressure of the pure component, it is given as 50.71 into mole fraction of benzene is 0.486. So when we multiply this, we will get the partial pressure of benzene in solution, that is 24.65 millimeter mercury. Similarly, we can find out for toluene also. So that is 32.06. That is the vapor pressure of the pure component into mole fraction of that component is 0.514. So when we multiply, we will get 16.48 millimeter mercury. Now we got the partial pressure of each component. So according to Dalton's law, we know total pressure is equal to sum of the pressures of the individual components. So let us add the pressures of each component. So 24.65 plus 16.48, that is equal to 41.13. Now we have the total pressure. Now we have to find out the mole fraction in vapor phase. So according to Dalton's law, we studied partial pressure of any component is equal to, here if we write benzene, P total into Y C6H6. So we have to find out the mole fraction of benzene, that is equal to partial pressure of C6H6 divided by P total. So we got the partial pressure of benzene as 24.65 divided by 41.13. So when we simplify, we will get 0.60. This is the mole fraction of benzene in vapor phase. Air is a mixture of number of gases. The major components are oxygen and nitrogen with the approximate proportion of 20% is to 79% by volume at 298 Kelvin. The water is in equilibrium with the air at a pressure of 10 atmosphere at 298 Kelvin if the Henry law constants for oxygen and nitrogen are 3.30 into 10 raised to 7 millimeter and 6.57 into 10 raised to 7 millimeter respectively. Calculate the composition of these gases in water. So composition of these gases in water means we have to find out the mole fraction of each component in water. So here first let us find out the partial pressure of oxygen, because it's given in percentage, 20% of 10 atmosphere. So partial pressure of oxygen is equal to 20% of 10. So when we simplify, we will get 2 atmosphere. Then partial pressure of nitrogen is equal to 79% of 10, that is equal to 7.9 atmosphere. Now let us write the Henry's constant for each case. KH for oxygen is equal to, KH of oxygen is equal to, here to 3.30 into 10 raised to 7 for oxygen. 3.30 into 10 raised to 7, the unit is millimeter, and KH of nitrogen is equal to 6.51 into 10 raised to 7 millimeter. So we know as the KH value increases, solubility decreases. Here you see KH values are given in millimeter, so we have to convert atmosphere into millimeter. 1 atmosphere is equal to 760 millimeter. So that will be 1520 millimeter of mercury. Next 7.9 into 760, that is equal to 6004 millimeter mercury. Now let us apply Henry's law. According to Henry's law, we know partial pressure is equal to, partial pressure of oxygen is equal to partial pressure is KH into mole fraction of oxygen. P is equal to KH into chi. So here partial pressure of oxygen is equal to KH of oxygen into chi of oxygen. Then now chi of oxygen is equal to partial pressure of oxygen by KH. Here partial pressure of oxygen we got it as 1520, and KH we got it as 3.30, it is given in the question, into 10 raised to 7. So when we simplify, we will get 4.61 into 10 raised to minus 5. Mole fraction has no unit. Similarly, we can find out mole fraction of nitrogen is equal to partial pressure of nitrogen by kH of nitrogen. So that is equal to, when we multiplied, we got 6004. So 6004 divided by, then constant 6.51 into Henry's constant. When we simplify, we will get 9.22 into 10 raised to minus 5. Determine the amount of calcium chloride I is equal to 2.47 dissolved in 2.5 liter of water such that its osmotic pressure is 0.75 atmosphere at 27 degrees Celsius. Here calcium chloride is an ionic solid, that's why I value is given as 2.47 and the osmotic pressure is given as 0.75 atmospheres. Then temperature is given in degrees Celsius, so we have to convert into Kelvin scale. So we will get 300 Kelvin. Then now we have to calculate mass of solute. So we know the formula, pi is equal to osmotic pressure is equal to I into Van Hoff factor into molarity into R into T. Here C is equal to molarity, that is number of moles of solute, that is mass by molar mass divided by volume of solution in liters. For that, first let us calculate molar mass of calcium chloride. So M2 is equal to calcium chloride, calcium mass is 40 and chlorine 32 into 35.5. So when we simplify, we will get 111 gram per mole. Now let us substitute in the equation. R value, let us write 0.0821 liter atmosphere Kelvin raised to minus 1 mole raised to minus 1. Now pi is equal to I into W2 by M2 into volume in liters into R into T. Therefore, W2 is equal to pi into M2 into V divided by IRT. So, osmotic pressure is given as 0.75 and molar mass we got it as 111. Volume is given 2.5 liter. Van Hoff factor is 2.47 and universal gas constant 0.0821 because liter atmosphere Kelvin raised to minus 1 mole raised to minus 1. Next temperature 300 Kelvin. So when we simplify this, we will get 3.42 gram. This is the mass of calcium chloride. Determine the osmotic pressure of a solution prepared by dissolving 25 milligram of K2SO4 in 2 liter of water at 25 degrees Celsius, assuming that it is completely dissociated. So here in the question it is mentioned potassium sulfate is completely dissociated because it's an ionic solid and strong electrolyte undergo complete dissociation. So K2SO4 dissociate in water to give 2K plus SO4 2 minus. So let us write the I value, Van Hoff factor, the total number of moles after dissociation, that is 2 plus 1, that is equal to 3 divided by number of moles before, so that is equal to 1. So Van Hoff factor is equal to 3. Then volume is already given in liter, so no need of any conversion, and temperature is 25 degrees Celsius. So 25 plus 273, that is equal to 298 Kelvin. Now we have to calculate the osmotic pressure. Before that, mass is given in milligram, 25 milligram. So we have to convert into gram. 25 by 1000, that is 25 into 10 raised to minus 3 gram. Now osmotic pressure pi is equal to I into C, mass of solute by molar mass divided by volume of solution in liters. Here already volume is given in liters, so we are not using 1000 here. Then ICR, that's the universal gas constant, and temperature it is also given. Now let us substitute all the values. 3 into mass of solute 25 into 10 raised to minus 3, universal gas constant 0.0821 into temperature 298 divided by molar mass of the solute. So K2SO4, we have to find out the molar mass, that is potassium 39, 2 into 39 plus sulfur 32 plus 16 into 4. So when we simplify this, we will get 174 gram per mole. Now let us substitute the molar mass here. 174 into volume is 2 liter. So when we simplify, we will get 5.27 into 10 raised to minus 3 atmosphere. 5.27 into 10 raised to minus 3 atmosphere.